Hi, everyone. Thanks for joining us for our 2025 Vermont Vegetable and Berry Growers webinar series. Fortunately, I think winter is officially over. We had snow. I was just telling Sue a couple days ago up here, and I'm hoping to take my snow tires off soon. But here we are, spring webinar. And really excited to have several Brassica pest experts here today. And we're going to start with Sue from UMass Extension. And I will stop sharing and let you introduce yourself more. But you're such an asset, and thank you for hopping on.
Thanks, Becky, to speak today. I'm Sue Scheufele from UMass Extension, and I've been working on Brassica pests for a long time now, and I'm just going to jump right in because there's a lot to cover. There's a whole bunch of Brassica crops that are grown kind of all season and all year on a lot of farms, and they have a lot of pests, and so that's what makes it especially challenging. This sort of very rough calendar shows just when the different pests are active, and it's pretty much all season. You're dealing with multiple pests and multiple generations of these things that are overlapping, so no wonder that it's a challenge. I'm going to focus on the first two here, flea beetle and cabbage maggot. They have some similarities in how they behave and how they can be managed, so I will just jump right in. This is cabbage root maggot. It is a fly, and in the spring, around this time in Massachusetts anyway, it emerges from where it overwinters in the soil as a pupa, and the adult flies start mating. They lay their eggs at the base of the plant, either glued to the stem here or on the soil just around the stem. And when those eggs hatch, the lovely maggots start feeding on the roots and cause this kind of damage. So transplanted crops see stunting, wilting, and this characteristic discoloration. The plant can't get enough water and nutrients. And on our root crops, this direct damage to the harvested root and subsequent rotting. And then the flea beetle is a beetle, and we see the adults above ground feeding on our brassicas. They also lay their eggs at the base of the plant in the soil. The eggs hatch into these super tiny larvae. We've never seen one. They're very small, and they do feed on the roots, but they don't cause usually any perceivable damage. Those pupate and then reemerge as adults to feed on the plants above ground again. And we see this kind of damage on bok choy and mustard and arugula. And then on the waxy brassicas, usually the feeding around the edge of the leaf, that can cause a lot of stunting of seedlings. And that's certainly something we want to prevent. Both of these have multiple one last reason to pay attention to flea beetles and try to keep them out of the field. They can also spread disease. This is a picture of flea beetle, and all these little white spots are spores of Alternaria, and they can also carry bacteria that cause black rot in their mouth parts. So our first tool in preventing these things is crop rotation, especially fall to spring. So if you leave your fall brassica residue in the field like this, like most of us do, that is going to be a prime overwintering spot for things like Alternaria and cabbage aphids and root maggots and flea beetles. So locating your spring crop as far away from the fall crop as you can. Certainly the worst outbreaks of root maggot that I've seen are where people planted spring brassicas near fall brassicas. It's also important to rotate in season as much as possible. It's tempting to plant everything in successions next to each other, but if you can put some gaps in between every time. It's like starting fresh until they find you. Tillage can be a good tool to use. Again, here's some residue that's just housing all of our Brassica pests here. If you can't deal with it in the fall, but you could mow it, that can speed up the breakdown of that stuff and reduce the pressure of overwintering pests. This is the title of this, I think, was like research-based tips. So this isn't research-based exactly, but a farmer that I've worked with over the years said after switching to finger weeders for their brassicas, they haven't had nearly the root maggot pressure, and this makes a lot of sense. We know that drying out the soil and heating up the soil has an impact on the egg and larval survival of cabbage root maggot. So there's actually 3 generations of cabbage root maggot. One in the spring that we worry about quite a bit, one in the summer that we basically don't worry about at all, and one in the fall that we might worry about with our fall turnips and stuff. The reason we don't worry about it in the summer is because so many of the eggs and larvae die that it's just not a problem. And the reason for that is the soil is too hot and dry. So these finger weeders are maybe moving the eggs away from the base of the plant, but also drying out that soil more quickly. So something I wanted to share. When it comes to root maggot, we know kind of exactly when this is going to emerge in the spring. There's a website you can go to, NEWA, NEWA. If you just Google it, it's like newa.cornell.edu or something. You find the root maggot model and plug in a weather station close to you and the date, and it will give you this graph and show you according to the accumulated heat so far in the season, measure the growing degree days, and cabbage root maggot emerges at about 450 growing degree days. So you can look this up and know for your location, this is when I need to be worrying about this spring flight and egg laying of the cabbage root maggot. You can also, if you're not into the computer model thing, we try to write about it in the newsletter and give you guys a heads up, but it also, the peak flight of the spring generation also coincides with flowering of yellow rocket. So if you have some of this and you see it flowering, that could be an indication that you need to be worrying about this pest. Or you could just use yellow sticky cards in the field, and you're looking for that little humpbacked hairy fly. So, and this will help you prevent that damage. Another way to prevent, which is, probably you guys are using these already, but exclusion is 100% effective for root maggot and flea beetle, as well as caterpillars and sweet midge. And it's a pain, but it does work. You have to get it on before the crop is susceptible. Make sure it doesn't have holes, make sure it's sealed up well. Sometimes folks worry about these 2 pests emerging under the cover because they are overwintering in the field. So if you put some of those yellow sticky cards under the remay, that could help trap out anything that does emerge under there, or at least tell you there is in fact stuff emerging under the covers. I want to make a plug for the netting, insect netting as opposed to remay. You can see right through it, so you can keep better track of the weeds underneath. The wind goes right through it, so it doesn't sail away like we tend to see this time of year. Already seen some remay in trees this spring. And again, it is 100% effective against all of these flying insect pests. A grower that I work with here in southeastern Mass recommended using the heavier weight, and that will last at least 5 years. And so it is an investment, but these are pretty high value crops, are spring radishes and arugula. So I think it will pay for itself in those situations. I wanted to make a plug for mulching and intercropping or using like living mulches. So there's a lot of research out there over many decades that shows we can interfere with the pest's ability to find the plants. So they are looking for the Brassica plants to lay their eggs at the base. The more non-Brassica plants are around. Okay, so this is obviously zucchini, not a Brassica, but it's a good picture of the living mulch. But the more other scents are around, they just can't find the plants as well. In the case of these mulches, just interferes with the ovipositioning. There's a physical barrier. Let's see. And so, yeah, you can reduce the number of flea beetles and damage the number of larvae and therefore the next generation of flea beetle adults. In the case of aphids, these living mulches can slow down the infestation of the crop. The aphids can't find the host in this sort of wall of green. They can only stay in this situation where you have the bare ground and then the plants. It's much easier for them to say, oh, that's a plant, I'm going to land on it. And so our colleagues in Long Island did a study combining the use of the insect netting. They wanted to look also at the plastic mulch because they knew they were going to have weeds under there. If they are covering, then they can't cultivate. So they put down the plastic for weed control and then decide to look at them together and separately, and found that with plastic alone, they had 98% control of cabbage root maggot. Again, because the plastic is there, the fly doesn't want to lay the egg, and the soil temperature around the plant is increased. So if there was an egg laid, it could be killed by that increased temperature. I'm like speeding through this, bear with me. You can take advantage of the flea beetle, in this case, preference for different types of brassicas. And I think when people hear about trap cropping, it feels complicated, but you can make it really simple and just, I've worked with a number of pretty large organic greens growers who just treat the bok choy as their trap. So they have all their waxy heading or leafy brassicas and then a row of bok choy about every 8th bed. And they only spray the bok choy and they get enough of a reduction in flea beetles there that the rest of the crop is protected. And so that's like a really simple way to do it. You can add, in this case, the farmer added surround the white kaolin clay to further push the flea beetles onto the bok choy. And it works pretty well as long as you are good about protecting the bok choy. If you miss a spray, then you'll end up with this kind of Swiss cheese bok choy, which is not ideal. Last point here is just you can skip a planting or delay planting and just break up the pest life cycle. If the root maggot or flea beetle are all emerging right now and there's no food for them, then they're not going to reproduce and survive very well. So I've had farmers who took a spring off from brassicas, took a year off from brassicas, or just delay the planting a little bit. And then using larger transplants, if you can, they're just going to be more resilient, and the bigger the root ball, the more likely the plant is going to be able to survive that root maggot damage, or in the case of flea beetle, the stunting. So once you've kind of used all those cultural practices, and it's time to look at insecticides. For root maggot, we have a couple of options. You can do a tray drench of Vermont or Admire. So those are conventional systemic insecticides, and you can apply them to the trays, which is very handy. And then they have a long residual period, about 3 weeks, and they protect against root maggot, flea beetle, caterpillars, and aphids for that 3-week period. These other products are not labeled for a tray drench, but field drench at transplant, and then at least 1 or 2 subsequent applications. So Entrust and Radiant are spinosad products. Entrust is organic certified, and those are pretty effective. And then Coragen is a diamide, conventional insecticide that again is systemic, but this one is not labeled for a tray drench. And so we, back 10 years ago now, we were looking at alternatives to Lorsban, which is kind of the conventional industry standard for cabbage root maggot. It has since been unregistered. You can't use it anymore. And that's a good thing. And it's a good thing that we have these alternatives. So here, down here is our untreated control with very low vigor. And Lorsban is this red line. So that's kind of our industry standard. And here we see that Coragen and Entrust are doing as well as Lorsban. And Vermont up here is doing very, very well. I'll say that we had this Entrust treatment had a tray drench and 1 field drench application afterwards. When we just did the tray drench alone, it wasn't enough. Also, when we were doing these studies, root maggot, this soil application for root maggot was not on the Entrust label. And the way that it did get labeled and is labeled now, the tray drench isn't allowed. What you need to do to get good control with Entrust is get the timing right. So paying attention to when the root maggots are laying eggs and making sure you have a field drench then, and then at least 1, if not 2, follow-up applications of the Entrust. This did correlate to increased yield. So again, here's the untreated, the Lorsban control, and Vermont doing better than Lorsban, and Coragen and the Entrust with the drench and field application as good as Lorsban. Our colleagues on Long Island, again, they did a similar study, and here's their untreated control with a lot of damaged roots, and the Lorsban control. Here's Vermont doing as well or better. Again, this is with a drench and a field treatment. Here they looked at, this is a beneficial nematode, didn't provide good control. They looked at Entrust, and again, when they had these 2 applications, was as good as Lorsban. I wanted to point out that they also included a row cover treatment here, which was better than any insecticide. So really, row cover is a great tool. When we're looking for insecticides for flea beetle, I'm gonna start with the organic products, because I do get a lot of questions from folks about what is the best organic insecticide for flea beetle. And it surprises me because it's been studied a lot and it's consistently found that Entrust is the most effective. And you can see that here. And the reason for that is Entrust is, it works on ingestion. And so you spray it on the plant, sticks to the plant, it stays there for about 7 days. The flea beetles eat it and then they die. As opposed to like the other thing that people use a lot is pyganic. and it does have a place in managing flea beetles organically, but it works on contact and it's very susceptible to UV degradation. So it doesn't have a residual really at all. So you spray it, you kill whatever flea beetles are in the field at that moment, and then they come right back. And so you could mix those two together and then you get kind of a double whammy. Or you only have a certain number of entrust sprays on the label before you have to switch active ingredients. And that's where you could rotate with Pyganic, and that's a good idea. And then I'll just say conventionally, there are a lot of products that work well for flea beetle, and they're listed in the guide. Here's a couple. This is a neonic, a pyrethroid, and this is our diamide, which is like same active ingredient as Verimark, but foliar applied. And those all work pretty well. The thing with the flea beetles is they'll keep coming. There's like 4 or 5 overlapping generations of flea beetles all summer long. You'll see kind of like little up and down in the pressure, but they're kind of here all summer long and you have to keep up on them. So I think that is all I have time for. I had a little bit about caterpillars that I'll skip for now, but just to go back to the beginning and say, we have all these different pests and brassicas. We need to take advantage of all these different strategies in management. And that's all I've got. Thanks.
Thank you, Sue. That's a lot of awesome knowledge, and thanks for shrinking it into a short time frame. I know we could give you an hour, but if we have time at the end and people have caterpillar questions, we can bring up some of your slides again. We're going to hop over to Becky Sideman from the University of New Hampshire, and she's going to share some information about cabbage aphids. So thank you, Becky, for joining.
Yeah, it's my pleasure to be here. Thanks for asking me. And yes, I'm going to talk a little bit about cabbage aphids, which are something that I have worked a bunch on, but not for a little while. And so I've repurposed a webinar from the Brassica Pests Collaborative, which includes folks like Sue and our colleagues at UConn and Cornell Cooperative Extension. And a lot of the work I'm going to share with you, I'm going to do it relatively quickly, but it's the work of a grad student, a former graduate student of mine, Alina Harris. I have her picture here, and Anna Wallingford also worked with us on this project. So I'm going to give you a quick overview on cabbage aphid management. So cabbage aphids, if you are a Brassica grower, you have probably seen these horrible little gray creatures infesting your Brassica crops. They're really characteristic and very easy to tell, even for a layman non-entomologist like myself. They have this waxy protective coating that gives them this gray look. A lot of growers refer to them as gray aphids. And they just look really different from all other aphids because of that gray waxy coating. They really love new growth. And so this makes them, you can see some really nice infestations on a broccoli floret here and on the top of the Brussels sprout where it's been topped. They love Brussels sprouts. They love axillary and apical meristems. They love heads of broccoli. So they're really problematic for a lot of our Brassica crops because not very many of them render the Brassica kind of unmarketable. They also get right into the sprout, so they're impossible to wash off. So from the point of view of understanding the life cycle of these guys, the eggs are laid in the fall on wild and cultivated brassicas. So we have to remember that there's lots of Brassica weeds often around and in our fields, and sometimes we even have brassica cover crops to add to the mix. In the spring, those eggs hatch. The wingless females that hatch feed and reproduce asexually, so we get multiple generations. Sometimes they start as they're visible as early as mid or late June, although that's earlier than normal. And when they're overcrowded and in stressful situations like other aphids, that triggers the production of winged females, and those are really hard to sort of predict their movement because they can then fly and disperse over a further distance. I show this picture because this is a high tunnel of broccoli that, it looks like it has problems for various reasons, but one of the problems that it had was cabbage aphids. And so just to keep in mind that if you've got brassicas, kale, broccoli, that kind of thing, in high tunnels, that's providing yet another overwintering site, and they're overwintering possibly as adults, not even as eggs. So that kind of changes the overwintering dynamic possibly for this pest. So when we talk about cultural practices for cabbage aphid, rotation, like Sue mentioned, for all the other brassica pests, rotation is kind of our first line of defense, particularly fall and spring, between the previous fall and the next spring, making sure that we aren't putting brassicas right back where brassicas and lots of cabbage aphids were. And just being aware that previous crop residues and wild mustards are sources of infestation. Yeah, it's also possible as a cultural practice to maintain some insectary plantings to support predators and parasitoids, although I'll talk more about that in a moment. That is another cultural practice we can employ. I think the number one thing with cabbage aphid is scouting, and it's actually, it's exceedingly important because they appear in small numbers first, and if you can stop them at that very early stage, you stand a much better chance of controlling them than if they get out of control and to those levels of those photos I showed early on. And so the very first signs are shown in this picture on the right here. They are yellowing of leaves. It's this funny light yellowing. And if you go and look at the undersides of those leaves under those yellowing patches, you'll find one or two little cabbage aphids just getting off to a start. And so the thresholds that we have suggest that treating if 10% or more of the plants have at least one aphid, which is not hard to do, that makes sense. And I think it makes sense to rogue heavily infested plants early on. So those infestations start by a couple of plants getting heavily colonized, and it is worth removing those to prevent further spread from those winged adults later. So scouting, roguing, treating as needed. These are some photos of, again, you don't see from these pictures the cabbage aphids, but they are on the undersides of those leaves. That bright yellow is a classic sign that there's cabbage aphids hanging out in there. So turning to chemical controls, there's a lot of options available. There's even more listed in the veg guide than this. That includes several conventional materials, systemic materials, newer materials like Movento that are effective. Of the organic options, we have to be a little bit choosy. And what it looks like, we've got a few options here. Azadirachtin, which only really controls the immatures well because it's an insect growth regulator. We have materials that interfere with the waxy coating of the aphids, like insecticidal oils. We have to be careful of phytotoxicity at high temp, and insecticidal soaps. And then pyrethrum, things like pyganic, which we have to remember is photosensitive, so that might warrant a nighttime application rather than a daytime application, although contact is going to be important with these materials. For chemical control, because the cabbage aphid builds up to such high populations, it's really important to, again, monitor super regularly, like weekly at least, and act early, like the moment you see those infestations. It also means, because you won't contact all of those aphids, it means repeating applications, especially if you're using materials that require contact, like insecticidal oils and soaps. Coverage is really critical, and that's tricky with brassicas because of their waxy coating, and the cabbage aphids is waxy coating. And so it means that spreader stickers can be helpful. That might include adding something like MP'd insecticidal soap, which can enhance coverage of other materials. It's possible that removing lower leaves, like for example, with a crop like Brussels sprout, can help improve coverage. And it may be that choosing nozzles and tips that maximize coverage is going to be really important for this pest, because just to try to get coverage in those cupping, turned over leaves, which can be tricky to reach. I mentioned before the idea of having insectary plantings. And in general, I think conserving natural enemies is a viable strategy. It's a helpful strategy as part of the picture for integrated pest management for brassica crops. There are a number of predators and parasitoids that do attack cabbage aphid. And those can be encouraged through insectary plantings and maintaining, flowering borders. We did some work with this. Alina did, coming up on 10 years ago. And alyssum is sort of a classic perennially blooming, very attractive insectary crop. It's also a brassica crop, so that brings in some challenges with using alyssum as a flowering plant. But you can see right there, there's a hoverfly on there, and those hoverfly larvae definitely parasitize and predate upon cabbage aphid. I did my homework of doing a little literature searching before this to see what else is new. This is not terribly new. This is old, but I had not come across this before. I hadn't understood that the cabbage aphids really, they have extremely high concentrations of glucosinolates in them because of their attraction for and feeding on brassicas. And so I love the title of this paper. They are walking mustard oil bombs. And so there is actually some quite new research suggesting that they're actually predating upon them or parasitizing them does sometimes have some negative effects on beneficials because of those compounds that are present in the cabbage aphid, which may explain why some of our work looking at using insectary plants for biocontrol wasn't super effective. They've got some built-in really high quality defenses in their little aphid bodies. So leaving you with this beautiful and inspiring photo of a real appetizing Brussels sprout. I'll finish with a little sum here. Important to identify the aphid. These guys are truly easy to identify. They feed on new growth. You got to scout early, act often, and keep going. If you're going to use chemical controls, you should probably use adjuvants to get really good coverage. Insectary plantings, I think, may be part of the strategy, but in our work, even with very good insectary plantings and lots of beneficials on them, we did not get what I would consider to be anywhere near acceptable control from those insectary plantings. So they're a part of the puzzle, but they're not going to bring high numbers like that down to nothing. I will also just say that we were not able to do any research on this topic, but one year that we were doing this research was a very moist year, and we had entomopathogenic fungi come in and really completely clear up a very bad cabbage aphid infestation. Cabbage aphid populations are higher in dry years than they are in wet years. And it is probably true that entomopathogenic fungi are naturally conferring some biocontrol. And there is currently a lot of research going on looking at entomopathogenic fungi and products to control cabbage aphid. And so I think that that is likely to be an area where there might be some future developments coming that I'm really hopeful for. And that's it. I think, are we saving questions for the end?
Yeah, I think that'd be good. I think we should also take a vote on the grossest Brassica pest or disease, because I think these are pretty appalling.
And also kind of cool.
Yeah, it could be like a enhanced mustard oil Brussels sprout, for
I never
example.
thought to taste them before.
Yeah, who knows? But thank you, Becky. Thanks for digging into the archives and stepping out of, back into flashback from the past. So it's great information and still super relevant. So thank you so much. And looks like you have some like lily research in the background or something.
A little
Keith.
side amaryllis breeding project.
Oh, cool.
Yeah,
Awesome.
the fun never stops over here.
Ethan, Teresa, are you guys ready to chat it up a bit?
Yeah, always. I'm Ethan Grunberg. I'm a vegetable specialist in Eastern New York. And my colleague, Teresa Rusinik, and I have been working on organic management of Brassica Alternaria for a few years. We've shared this work before. We shared it in the New England conference a couple of years back. So if you've seen it before, you can take a little nap before you head back out to the field at 1. No worries. And Teresa will chime in as she feels inspired to. So my guess is that most of you are dealing with Brassica Alternaria, especially on any of your crowning brassica crops. We see it especially in wet years, especially in the fall when we get heavy dew sets that don't burn off until early afternoon sometimes. And best case scenario is you end up with foliar lesions that look like that kind of characteristic trademark sort of ripple in a pond look, the concentric circles that these Alternaria species create. But oftentimes those foliar infections result in infections on the crown and the bead. And obviously you don't want broccoli that looks like that, not marketable, smells awful. You often get secondary bacterial soft rot pathogens that colonize that compromised crown in there as well. Then you got maybe a contender for as gross of a brassica pest as a cabbage aphid, maybe a close second. Certainly the olfactory impact, I'd say, is worse than the aphids. But as I think Sue and Becky already did a great job doing, obviously when we're talking about fungicide programs or chemical controls of any time, it's important to keep in mind that that's just one tool in our toolkit in terms of managing these pests and diseases. And for Brassica Alternaria in particular, all the standard tools of crop rotation, trying to reduce, the amount of moisture on those plants by drip irrigating when possible, spreading those crops out a little bit if you're in a situation where, again, you have really heavy dew sets in the fall just to get better airflow and lower relative humidity right in that crop canopy. These are all things that can help. Anecdotally, and in a couple of trials done in the mid-Atlantic, varieties that have more of a domed crown, like a lot of the varieties that have crown in the title of the variety, help kind of shed the water off that crown and help reduce Alternaria severity on the broccoli a little bit. But we're going to focus in on a bunch of work that we've done with organic fungicides for managing Alternaria. At the end, in case there are conventional growers on here, I'll also share a resource from our colleague Christy Hopeting in Western New York, who puts together kind of a fungicide cheat sheet with conventional chemistries for Brassica Alternaria management every year as well. I always appreciate that, Teresa. Let's us keep this picture of her doing field evaluations in the slide because it's a great look. We can all take, if nothing else, some style lessons from Teresa from this presentation. Over 3 or 4 years, we trialed a bunch of different programs, and basically, to cut to the chase, the only thing that worked in our trials was a somewhat new product called OSO from Certus, which is a polyoxin D zinc salt product. And so this is sort of just the summary of the programs that we found that worked really well over the course of our trials. Okay. And so I know, I used to be an organic grower in Massachusetts, and I would never start a fungicide program immediately after transplant because I'm cheap maybe or lazy. Maybe that's why I no longer work as a farmer. I work in extension. But so I think some of these programs where we wait to initiate a fungicide program until like week 3 or 4 after transplant might feel like a better place to start for some growers. And I want to make sure, even though these programs are included from a research perspective, where we came back week after week after week spraying the exact same thing, we don't ever want to recommend that for a resistance management perspective. Even though Badge X2, which is a copper product, and OSO, neither one of them actually has mandatory rotation restrictions like Sue was talking about earlier with Entrust, where after like 2 sequential applications, you have to rotate to a different mode of action. Those restrictions are not on either of those product labels. But OSO in particular has a like medium risk level for pathogens developing resistance to it. So we really want to be careful to preserve the useful lifespan of that product. As we see like Entrust start to slip and different species develop resistance to it in the organic farming world. It's like a little cautionary tale of let's not overuse one of the few chemical tools that we have in organic ag that seem to work well. All right. So instead, we can focus on these other programs where, again, you can kind of see the common feature of these programs that worked for us is that OSO is slotted in here 2 or 3 times, kind of starting towards the tail end of that production cycle of the broccoli in the field. So if folks are reluctant to use copper products for whatever reason in their production, we found good results from this combination of Regalia and Stargus as a substitute for Badge in a program. We'll share one slide briefly at the end that will make it very clear that's a much more expensive alternative to Badge. But I think there were a couple of years of that as well, where like these Badge OSO tank mix combinations, where we're at heading already, where that crown has already started to emerge. We, under the right sort of environmental conditions, did see some phytotoxicity, a little bit of burn on those broccoli crowns where we had Badge in there late. So I think I'm kind of settling on over time, not having Badge on late, maybe just sticking with something like this where we have OSO on in weeks 4, 6, and 7, with some Badge mixed in there earlier if you feel like you need it. So where do we get all this data from? How do we generate it? We took some basically disease severity evaluations in the field. Teresa is a master at estimating the percent of a broccoli crown that has visible Alternaria symptoms. And so what we're really looking for is broccoli that looks like this on the far left with that 3% coverage or less. You can see once we start getting 5%, you get these little areas like this. If you can see that on the screen there, that really, if you've seen that go into the cooler and you pull it out 3 days later, oftentimes that's spread over much more of the crown. And what we really don't want is this whole area with all of these sunken black lesions. It's a little bit hard to see in this picture, but there's little Alternaria bits all over that crown over there. All right. So I know growers hate bar graphs, especially when there are lots of treatments involved, but bear with us for just a second. Really focus over here where we have the most effective programs. So this is a summary of basically what percent of that broccoli crown at harvest had visible Alternaria symptoms on it. And again, really what to focus on is the word OSO in here. You can see our programs that used OSO as kind of the cornerstone of it. This is where we sprayed OSO 7 times in a row, which we do not recommend that you do. We basically, in this year, which was a dry year in 2022, with relatively low Alternaria pressure, we were almost able to eliminate Alternaria from those crowns at harvest. All right, compared to the untreated control, where on average 35% of that crown had visible Alternaria symptoms on it. Okay. So again, just sort of a visual here of what that looks like. Again, our untreated control where we sprayed nothing, that's not marketable broccoli. I've grown broccoli that looks like that, I'm not proud to say. But no one wants to grow broccoli like that. I'd much rather have broccoli that looks like any of these other pictures. Even where we sprayed badge just by itself 7 times in a row, we got some reduction, but there's still quite a bit of Alternaria in there. So it's really looking at trying to incorporate a few targeted OSO applications, rotating in with something like Regalia and Stargus in this image here, where we have really nice lush broccoli, or just OSO by itself towards the end, especially to avoid that risk of phytotoxicity. This is basically just another way of showing the same data, right? Which is this is how many marketable crowns that we had, or the percent of marketable crowns that we had at harvest. Again, where we had OSO as part of our program, we had pretty good results. Definitely better than doing nothing, where only like 18% of our crop was marketable at that 3% threshold for disease severity. All right. So it's really easy in our position to sit here and recommend fungicide programs that cost a lot of money because we don't have to pay for them. But we understand that that growers care about the cost of these products. And so again, I'm just going to go ahead and X out the programs here that we would not recommend, just from a risk management sort of resistance management perspective. And we'll focus on the ones that we could adopt as growers. So you can see here where we delay the initiation of the fungicide program until either week 3 or week 5, and we're using copper in there in addition to OSO, that we end up with cost per acre of anywhere from $120 to $200 per acre, which is maybe not what you're used to as a grower. But again, depending upon how much you're losing to Alternaria, if we can reduce our losses from having 18% marketability and increase that up to 90% marketability, it pays for itself in a year that at least has moderate to low Alternaria pressure. Okay. Now, this is where I mentioned if you're copper averse and wanted to try that Regalia Stargus tank mix combination in alternation with OSO, it's a great program. You're going to pay a lot more for it. And Teresa, I think, I don't know that we updated these prices in the last couple of years either. So basically quadruple all these prices. It's going to cost you $10 million with tariffs now to adopt any of these programs, right? But so again, just trying to think about what your typical losses are from Alternaria, how much you're selling for, what your market is for broccoli, and whether it might be a cost-effective approach to try some of these programs, even with a reduced spray program, working in some copper and OSO, especially later in that production cycle. I don't want to take a whole lot of time, especially on a beautiful day here. And I really appreciate Becky's discussion of the use of adjuvants in organic ag. It's a really sadly understudied area, and it's really tough to do effective research on it, given all the different products that are on the market and all the different sort of combinations and target pests that need to be studied. But Tress and I have been doing some work with OMRI-listed adjuvants. We did some work trying to see if the adjuvant selection in combination with an application of OSO could improve the control of Alternaria that we got. So this is work that we did in 2023, where we looked at spraying OSO 8 times in a row, which again, we're not recommending that you do. And then we used OSO by itself, OSO with a product called Attach, which is a spreader sticker manufactured by Loveland. It's sort of similar to New Film P, but not as sticky and doesn't coat all of your equipment and that terrible sticky residue. And then also a product from Rovenza Next called Oro Boost, which is sort of a spreader and penetrant. We didn't see really crazy results that are fun to share with growers in this trial. You know, we saw a very slight numeric improvement where we used that spreader sticker attach. Again, you know, as Becky mentioned, with these really waxy leaves, trying to have something that's going to spread that product out to get good coverage, but then also keep it on the waxy leaf so it can actually do what it's intended to do on the target pathogen. It's something that we recommend, even if we don't have the research data that really always shows that. But again, here's just another example. Yeah, the cost is there of adopting that program, but we got our average percent of the crown covered with disease symptoms down to about 8% from 40% that year. That was a wetter year with a lot higher pressure. Other quick tips, and I'll wrap it up here. When we're talking about trying to, you know, optimize an OMRI-listed fungicide application, all the basic maintenance on your sprayer, stuff that's often overlooked. You know, I just calibrated a couple research boom sprayers for the season, and the strainers were totally encrusted in some sort of weird gunk from last year that would have, you know, changed my flow rate and coverage and spray deposition pattern. A lot of specialty crops growers that I'm working with now have adopted these turbo twin jet type nozzles from T-Jet. I get no kickback from T-Jet. I wish that I did. But you basically get a spray pattern from two different angles as you're moving across the field. So it's really good at sort of penetrating into a dense canopy. It's also, you know, they tend to be finer droplet sizes, so they're a little bit prone to some drift, but you do get very good coverage in there. And just watch that PSI range. I've seen growers that like to crank it up to 80 and get very fine mist as a result, but all that stuff blows away off target. I'll leave that summary slide up there for just a second. I know it's a lot of information to take in quickly. Bottom line, though, is that, you know, mixing in a little bit of OSO, especially later in that broccoli production cycle, has very consistently reduced our Alternaria pressure in broccoli over the years, with maybe the exception of if it's a really crazy, terrible wet year and Alternaria pressure is out of control. OSO is not going to be a silver bullet for you. You're going to end up spending the money on the fungicide program, and you're still going to have an unacceptable level of Alternaria pressure in your crop. So I'll leave it at that. And Teresa, I didn't know if you had anything that you wanted to chime in with that you thought I overlooked.
Nope, I think you got it all.
Thanks to both of you. That's really great research. And we will post your slides and your presentation because there's a lot to digest there. And pretty cool to think about combating Alternaria. I agree, it's one of the grosser. definitely ranks for smell up there. We have time for some questions. I'm happy to hang on after. I know there's been some chitter chatter in the chat, but I also Vic Izzo is also here with a little bit of Swede midge knowledge. So if people have specific questions about Swede midge, feel free to pipe in with that. Well, thank you, all of you, so much. I know it's a pain to get a webinar together, especially on a gorgeous Wednesday afternoon during school vacation. So thank you very much. And we'll post the recording and slides. And there's one more left next Wednesday, same time. And we will be talking about neonicotinoids. So stay tuned. But thanks, everybody.
Thank you.
Thanks so much, Becky, Ethan, Teresa, and Sue. You guys are the best.
Thanks, Becky.
Good seeing y'all. Take care.
Nice
Thank
to
you,
see you
guys.
guys.